Some exercises from this worksheet right here. In the first case, exercise 1, we have a compound expression that involves and. And is a Boolean operator, also known as a logical operator, and we'll get to it according to the order of operations. The first step here would be to perform the addition, the mathematical addition of 3 plus 4. So showing work and being careful, since time right now is, I'm not rushed for time. I'm going to simplify that 3 plus 4 to 7, and I'm going to rewrite everything else. Being careful to rewrite everything else keeps you on track. I spread it out so that I can simplify things and show what happens in each step. So in the next step, I line up the equal symbol, of course. And the next step, I will simplify the 7 minus the 2 and put the 5 right under the subtraction symbol, just to be careful, and I write everything else below its corresponding part in the previous step. So I did the addition and I did the subtraction. Even though there were no parentheses, those two mathematical operations, part of Please Excuse My Dear Aunt Sally, they had to be executed first or evaluated first. Now I'm to the point where relational operators, also known as examples are greater than, less than, greater than or equal to, less than or equal to, not equal to. Those operators come next in this exercise before the and operation. And is lower on the totem pole, as I say, according to the order of operations. We already discussed how addition and subtraction were up here. They were actually tie. We worked from left to right. These are all tie. You would evaluate them from left to right. And is next. And when we eventually get to exercise 2, or is next after that. Right now, I'm not going to address the not operation. So there's a nice little handy chart, a reference as to the order of operations. Don't forget about multiplication and division. You probably will not see division in these exercises in this category of ACSL. You may see multiplication. Our next step here, the greater than symbol now has to be evaluated. So 7 greater than 6, that doesn't turn into a number, that turns into the concept or the Boolean value true. I like to write true with uppercase letters in this particular category of ACSL, Boolean algebra, and of course gets rewritten as an operator. And I'm going to evaluate this operation, 5 greater than 6. You should know that that's false, so I would write false. If this were a timed test, I would just put an F on my paper, but right now I'm being very clear in this video. True and false is so far what this original expression has translated to or evaluated to. Next, the AND operation. The AND operation, in another video somewhere, perhaps, you might have seen me analyze that if you have a left-hand operator, perhaps called A, this left-hand side, we'll just call it A. And if you have a right-hand side, perhaps we'll call this B. If you have 2 falses, I'm going to shorten the word false to false here. And then you have to evaluate whether that result is of false anded with false. If you have to evaluate the overall true or false of it, it would be false. If you have a false anded with a true, this is situation number 2, the overall result would be false as well. If you have a true anded with a false, the overall situation is false. And only if you have a true anded with a true would the final outcome be true. This is the same as the word and in normal English speaking. If somebody says, you have to eat your asparagus and your broccoli in order to get dessert, well, only if you did true eat your asparagus and and you did true eat your broccoli, only then would you get dessert. If you did not eat broccoli, or in this case, if you did not eat asparagus, or in this case, if you did not eat asparagus, nor did you eat broccoli, in those three cases, you would not get your dessert because and requires both sides to be true. Well, in this case, this side is not true. So this situation that we have right now in this exercise is similar to this scenario right here on our famous truth table. This as a whole is called the truth table. This is the truth table for just the operation and. We'll later talk about in this video the or operation, but there are four situations here. There are only four situations when you involve two possibilities of a left-hand side and a right-hand side. These are the four possibilities. Anyway, the final answer here is false, and I would put the false right under the and to show that the whole thing's simplified to false. It's very important on ACSL exercises, at least on the test, to put the answer in the right format. I would be safe and not just write an F. I would write it out in all capital letters. You could probably get away with writing it in lowercase, but for Boolean algebra, given the heritage of George Boole, who did a lot of this work in the late 1800s, George Boole is famous for working with trues and falses, and we like to always capitalize true and false in this type of mathematics. Next exercise. It's a lot more involved. It has an and, it has an or, and it has a not. Three Boolean operations, as well as some mathematical operations, as you see, the plus and the minus, and some relational operators. Don't forget about your less than symbol, your greater than symbol. Okay, let's proceed. The first step, working from inside the parentheses out, this turns into 7, this turns into 5, and that 5 plus 1 is 6. Rewriting everything else right directly below the original. I'm going to keep these parentheses here just to be safe. Later, I can get rid of those parentheses. I'm running low in space there, but being very careful not to add or omit anything. I'm copying everything down exactly below where it was in the original problem. So it's a little sloppy here, I'm sorry, but you can pause the video. So I just simply simplified a little bit of the math there, those three steps. The next step, rewriting all this, but simplifying a little bit at a time. I'm now up to where these parentheses have to be executed or evaluated, and they involve some relational operations. So working from left to right, 7 less than 6, that's false. I'm going to abbreviate to just F in this case and not write it out as the word false. This 5 greater than 6, that's a false simplification, and 6 equals 6. So I'm asking, is 6 equal to 6? True, it is. True. Rewriting everything else? Rewriting everything else from the previous step? Not. I'll keep these parentheses here just to be safe. You never know when, as a beginner, you never know when they're, well, you do know when they can be erased. But right now it's safer just to keep them there. And don't forget about your knots. They have to be evaluated towards the end of this exercise. So there is the next step. A little sloppy, but it's good enough. Now I'm to the point where I have to decide which comes next, not, and, or, according to order of operations. Well, not is a unary operator. It only works with one thing instead of and, which works with like two arguments or operators or operands. So not will almost always be followed by a set of parentheses unless you erase them, which you shouldn't have. So the not of the false is sort of like, what's the negative of the positive number 5? Well, it's -5. So in this case over here, the not of a false is the opposite of false. And the opposite of false is, well, true. So in other words, the operation not, if you were to evaluate it, you really don't need both columns A and B. I'm just going to focus on column A. The not of a false is true, and the not of a true is false. It's just pretty common sense to black and white, binary, on or off, and that's the simplification of not F. Now that I've dissolved those parentheses, I'll rewrite this parenthesis and I'll rewrite the and, but I really don't need to keep the set of parentheses around that F that sort of are now meaningless. These parentheses around the F, there's no not there in front of it, so they're unnecessary, so I'll just repeat the F. But this parenthesis here, I will keep that. And now I'll rewrite my or, and this not true, that simplifies to the opposite of true, which is false. So this set of parentheses is still fairly important. Just I'm glad I kept my careful notes. Now, it's always necessary to do parentheses before you do anything else, according to the please excuse my dear Aunt Sally. So true and false actually refers me up to the truth table. And you know how and works. Only if both sides are true does the whole thing simplify to true. And in this case, that false sort of ruins it. So this does not simplify to true. In this case, this simplifies to false. The true and false, just like we saw up here, true and false turned into false. Just like we see over here in our truth table, true anded with false is this F on the chart. So this part of it here is false. Now there's still a set of parentheses there that they really don't need to come along to this next step, because we're only left with the final step here of false or false. False or false. Well, I don't have any notes here on this worksheet for or. So I'm going to rebuild my truth chart right here for or. Now this was for and this column here was for not. I'm going to make a column for the operation or. I'm going to review again the 4 possible scenarios in which if you have 2 operands with an or operator in between, what are the 4 possibilities if you only can stick trues and falses in here? We can't put numbers like 3 or 5 in here. That's not the type of variable that we're talking about. A is a variable, but it's either true or false. I always like to put my falses first in a truth chart. Then I like to do the case where it's false in T. Then I like to do T and F. And then I like to do the true and true, or the true combination. These 4 possibilities exist. And this situation here that we've encountered in exercise 2 is when you have a false and a false. So we're going to be looking closely at this row of the truth chart that I'm drawing. But if somebody says to you, you can have your dessert if you do eat your asparagus or you eat your broccoli. Well, if you chose to false and not eat asparagus, as well as false, you did not eat broccoli, because the word or was giving you a choice and you didn't take advantage of either of those choices, you still were, well, a bit picky and you didn't eat asparagus or broccoli. Maybe you weren't just hungry. Either way, you don't get dessert if you didn't eat any of your vegetables there. So the final simplified result here is false, because that's the way the word or works. So these two go together here, false or false. It turns into false as the final answer. I would be safe on an ACSL test to not just simply leave it as an F. The person who's grading it might see it and think it's a T if you're sloppy with your handwriting. So writing it out is always safest, in all capital letters to be safe. Let's finish evaluating this truth chart, even though we didn't need anything else besides this first row over here. If somebody says, you can have dessert if you eat asparagus or broccoli. If you don't eat asparagus, but you do, true, eat broccoli, then true, you do get your dessert because you didn't eat one or the other. You ate the broccoli. In this case right here, the third case down, Yes, you ate asparagus. You did not false eat broccoli. You do get dessert because the or is very permissive. It's kind of be easy. And obviously, somebody who eats both vegetables, they get their dessert based on that rule. So there's a little truth chart for the operation or. Here was the truth chart for and. And now let's do this last exercise on this video. Working from inside the parentheses out, 4 times 8 is 32. 3 plus 30 is 33. 2 plus 9 is 11. 14 minus 2 is 12. 9 minus 2 is 7. Rewriting everything else, carefully pulling along the parentheses and putting them where they really should be relative to those simplified numbers. And I now have the next step that you see right here. Don't forget your equal symbol if you want to be exact like I am. And now we proceed on to take care of our relational operators. So our relational operators, 32 greater than or equal to 33, that would be false. I'm going to write it out since I do have room here. And 11 not equal to 12, that is actually true. And over here, it's a little sloppy, but 8 greater than 7, that's true. Rewriting everything else that comes along for the ride into this step of scratch work. I still have that not with the set of parentheses. That's important. I still have the and. I have this right parenthesis. I have the word or, and that is the next step there. The next step, I need to evaluate the not because it has the set of parentheses and it is higher than and or in the order of operations. Well, sorry about that. The not of a false is simply the opposite of a false, which is true in the world of Boolean algebra. I rewrite this and. I'm keeping the set of parentheses here and the outer set of parentheses. And I still have the or true coming along for the ride over here on the right-hand side of this large expression. The next step would be to look at the parentheses. I have parentheses. Now, even if those parentheses were not there, I want to make a point, even though it's not technically necessary to know this for this exercise. If you have ands and ors with no parentheses, you always do the and operation before an or. So that's why I put and higher on this totem pole than the or. So true and true. We did have parentheses here just for the record, but when you have a true anded with a true, you'd refer to this row of this truth table up here, true anded with true. Yeah, heck yes. If you eat your asparagus and you do eat your broccoli, of course you get your dessert based on the way the word and works. So I'm putting the word true, very sloppy at this point, but all of this simplified to true right here. And I still have this or true. And finally, I have one more step in the scratch work, and that is to evaluate true or true. That would be this column here of this truth chart right here with the or, true or true. It does yield or simplify to true. So I'm writing my true neatly under the or there since I have plenty of time. I'm not under pressure for a test. Writing the final answer as true. And if you have any questions, let me know. If you can reach me. This was a review of Boolean algebra evaluation of expressions.